Hello, I'm Long. Have you ever been trained to use an equipment and felt like you understood? Then on your first session alone, you're like, what button do I press? This is a common problem that can be resolved with a good standard operating procedure, or an SOP. Every equipment is designed and engineered to perform a specific job. An equipment alone cannot do anything. It needs a human operator. Human operators come in many varieties with different language, culture, values, knowledge, skill, experience, health, etc. The common practice is for the manufacturer to provide an operation manual and initial training to the custodian. The custodian is a person who might be more knowledgeable, skilled, and experienced than the average user at their institution, or they might simply be the most convenient person to do the job. My own experiences suggest the latter is vastly more common. A good custodian will put in the time required to become proficient with the equipment before training others, but this often does not happen because time is a scarce resource. No matter how complex the equipment may be, the human operator is simply pressing a sequence of buttons. I wish every equipment manufacturer provided an SOP, a document that tells us step by step which buttons to press. And here's an introduction to what I mean. I was inspired to develop a modern SOP when I replaced my iPhone's battery following an online guide at ifixit.com. Isn't it amazing that someone who has never opened an iPhone before can follow 21 step-by-step instructions without any assistance and fix their phone? The folks at iFixit provides clear instructions using a combination of photographs, text, and annotations. In this example, a red box in the photo focuses the operator's attention to a connector. A red bullet point informs the operator that the connector is for the front-facing camera and sensor cable. A plastic tool is shown to lift the connector off. With instructions like this, it's very hard to do the wrong thing, even when you know nothing about electronics. So how can we apply this to develop an SOP for operating scientific equipment? Well, at UHNF, the spirit of our SOP is to serve as a foundation for initial training and ensure that the equipment can be operated correctly by everyone, the first time, every time. So let's dig into it using an SOP I recently developed for the Filmetrics ProFilm 3D. On October 5th, 2023, I received the Filmetrics ProFilm 3D in a crate. The tool is simple enough for me to self-install following instructions on a single sheet of paper. I proceeded to spend the next few days self-learning how to use the tool by measuring a standard, measuring difficult samples, reading the operation manual, watching YouTube videos on white light interferometry, and so on. This prepared me for the training session with the company where I can ask good questions about things I haven't figured out yet. Then I asked myself, what's the simplest way to use the tool, and what's the minimum information the operator needs to know? The answer to these questions become the first draft of the SOP. In the second draft, I revised the instructions to protect the equipment from damage. The tool is equipped with two objectives. If a sample bumps into the objective, it will need to be replaced, costing up to $5,000. Shown here is the position of the objectives at the lowest position, so it is impossible for the user to crash the objective into the stage. From this test, knowing the free working distance of the 10x and the 50x objective, I deduced that the gap between the 50x and the stage surface is approximately 2.8 millimeters. The stage can tilt plus or minus 5 degrees, but it should be flat under normal operations. Thus, I specify that samples should be flat to within 1 millimeter. This ensures that if an operator is focused on the lowest point using the 10x objective and decides to swap to the 50x objective, there is no risk to bumping the 50x objective into the highest point on the sample. Explaining this during training is a waste of time because students who don't need to know this knowledge will forget. When teaching or training, the less you say, the more they might remember. Since the SOP is provided, the student does not need to take notes, which is distracting and a waste of time. No student will ever produce quality SOP because it is not their job, they lack knowledge and skill, and they are not responsible for the equipment. An equipment without an SOP is taking a huge risk. The riskiest procedure is to focus on the sample. The objective could be moved down using the single arrow button, but it moves really slowly. Many users will immediately use the double arrow buttons, but it moves too fast and it is easy to miss the focus position. An inexperienced user might keep going until bumping the objective into the sample. Perhaps the safest and quickest way to perform this step is to set the objective position at a sample height plus 2 mm, then run the autofocus routine. I have reduced that the actual focus position is sample thickness plus 1.1 mm. Autofocus will scan from a 1/4 mm below the sample to a 1/4 mm above the sample. If the sample is not in focus, then it will move the objective 0.5 mm lower and repeat the routine. Thus, it is safe to instruct the operator to move the objective to sample height plus 2 mm. It is safer to specify more than 2 mm, but at the cost of spending more time getting into focus. It is important to acknowledge that no single instruction can accommodate every application. The objective of the SOP is to cover the simplest application to familiarize the operator with the basic operations. From this foundation, it'll be easier to learn more advanced operations. The operation manual teaches to adjust the knobs to make the interference pattern either horizontal or vertical. This instruction requires the operator to make choices, and it's difficult to make the right choices if you don't understand the mechanics. This tool uses a special objective that produces an interference pattern on a tilted surface. The brightest band in the interference pattern is in focus. The next brightest band is out of focus by 1 wavelength. Thus, the interference pattern provides information about the tilt in the sample. Horizontal bands means that the stage is tilted only in X, whereas vertical bands means the stage is tilted only in Y. Thus, turning the knob highlighted in blue to produce horizontal bands is 100% correct. Turning the same knob to produce vertical bands is 100% wrong. Do you want your operators to make a mistake 50% of the time? When an instruction does not produce an anticipated result, many operators will start experimenting. At this point, you cannot predict what they will do. Once again, I will emphasize that an SOP is designed to tell, not teach. Most operators do not care what the equipment is doing. They have a job to do and may not have the time or curiosity to appreciate the technology. Time spent learning how an equipment works is time spent away from doing other important things. Operators who follow a good SOP are doing the right thing, whether they know it or not. For example, the ProFilm 3D uses an LED lamp with a rated lifetime of 40,000 hours. If we leave it on all the time, it will need to be replaced within 5 years. Due to its design, it can only be replaced at the factory. Turning off the system risks bumping the tool off the base because the switch is behind the tool. Also, turning off the tools will waste several minutes of time for the motors to initialize. After much consideration, I think the best choice is to set the lamp intensity to 0. The operator is effectively extending the life of the tool without even knowing about it. The decisions behind an instruction can be as complex as the author's soul. I like to take good care of my tools, so this part of me is infused in the instructions. I also want people to learn about the equipment. Instructions are preceded by colored bullet points. Follow the instructions to complete a step. Some steps provide information which is preceded by an eye-shaped bullet point. The objective of information is to teach the operator something they need to know to become a better operator. When you press the start button, the tool will do many things over the next minute. The tool will autofocus on the sample, move the objective down to a specified amount, then scan upwards a specified amount. During the scan, it'll capture a series of images that will be processed before displaying the result. The information is intended to explain or trigger questions in a curious operator. They will either figure it out on their own like I did, ask an expert for the answer, or just ignore it. Once again, knowing and understanding is not a requirement for operation. I run an academic nanofabrication facility with many high-tech scientific equipment. I tell our students that if they are still following the SOP after 5 years, then they have failed to learn anything and do not deserve to graduate. To encourage learning, there is no penalty for making a mistake for not following the SOP. Follow the SOP when you are new, but do what you need to do to wean off of it as soon as possible. There are many flaws to being human. It takes forever to learn something, and then you forget after months or years without practice. The riskiest operators are the new ones because they don't know any better, but also the experienced ones who are overconfident. Since we began providing thoughtfully engineered SOPs, we have effectively eliminated operator errors. Sometimes, users who forget how to use the equipment come find me for help. I will tell them to follow the SOP, and if they really feel uneasy, then come get me. They never come back and the equipment is fine. We haven't completely eliminated operator errors. Mistakes still happen when operators are too tired or mentally not present. SOPs are easier to write when companies engineer their products for the average human operator, but doing so takes a significant amount of knowledge, skill, and resources. Currently, I am not aware of any companies that provide an SOP. I hope they do so in the future, since I believe it will greatly help their engineering team to develop better products. A universal human trait is that we are all lazy. We want to spend the least amount of effort to do only what is required. It is also this nature that drives innovation. How do I do my job better using less effort? Can I eat more cake and not get fat? Well, writing an SOP used to be very challenging. You needed a fancy digital camera and it takes skill to take good photos. Files are stored in hard drives and it's a big hassle to share it or collaborate. This is not even 20 years ago, but it feels like ancient history. Well, I'm happy to announce that the barriers to writing and managing an SOP are effectively gone. With my smartphone, I can take excellent photos when I operate the equipment. I can add the photos into documents and annotate it on the spot. I can allow others to help edit the SOP. Users can effortlessly send comments or complaints to help improve the instructions. To further reduce the barriers to writing an SOP, I have written an SOP on how to write an SOP. I also publicly share most SOPs I've written. You can use it if you have the same equipment or learn from it. I have provided a link to our SOP in the description of this video. I hope this presentation has encouraged some of you to write one. If you need help, let me know. Thanks for watching.